Hello everyone, how are you all? I hope you all are doing very good and you all are learning from our YouTube channel Bhouthics, in which we have created separate playlist for each previous year questions of CBSE Class and Physics of each chapter. And we also have uploaded one more playlist, that is experimental learning, in which we have explained all the equipments which you study in CBSE Class and Electricity chapter. We hope that you are enjoying our education, the way we teach and the way we bring our content to you. And today I have brought you the most difficult concept which children will think. Actually, this concept is not difficult, it is very 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 easy, but children will think that this concept is very difficult. That is none other than the refractive index of any medium. Okay, so without making any delay, let us start the video. See, to prepare this video, I have postponed to prepare this video for 3 times. This time I have fixed to prepare the video. Why? Because there is so much information to be explained about refractive index, very much, very high content. But what I have fixed is what is required for student, for a CBSE class 10 student. And if I teach this much content, he should be able to solve the problems that are asked in CBSE class 10. That much content I reduce the content of refractive index to you, which is suitable for you, which is required for you. So after giving the content, fixing the content, I have selected some problems. First, we are going to go with the theory of refractive index. Afterwards, we are going to solve some simple problems. Afterwards, we are going to solve some previous year questions on this refractive index. So, without any delay, let us start this concept of refractive index. So, what is refractive index? What is refractive index? Refractive index means it is a index of refraction. What is refraction then? Refraction means what? Bending of light. Correct? To know what is refraction, you should be knowing first about optical density. See, optical density. What is optical density? It is different from mass density. Optical density is different and mass density is different. Optically denser. If any medium is optically denser medium, in that medium, light cannot travel faster. Light will travel slow. Means in any medium, if light is unable to travel faster and light is able to travel slowly, that is known as optically denser medium. And next, optically rarer medium. What is optically rarer medium? If in any medium light is able to travel fast, in any medium light is able to travel fast, then that medium we term it as optically rarer medium. There are so many examples. There are so many examples for denser medium and there are so many examples for rarer medium also. But when light travels from optically rarer medium to denser medium, then refraction will happen. Correct? So these all things starts here. When light starts from optically rarer to denser or optically denser to rarer, if the light is passing from rarer medium to denser medium or the light is passing from denser medium to rarer medium, then refraction will happen. What are the things that happens in refraction? You know, definition of refraction, it will be bending of light ray when it passes from one optical medium to another optical medium is known as refraction. Okay, these all things I am not going to write now. But what happens when refraction happens? What are the things that will change in light ray? What are the things that will change is, first thing, speed of the light will change. Correct? And the second thing, wavelength of the light will change. And third thing, phase will not change. And the fourth thing, frequency also will not change. What are the things that will change? Speed of the light will change and wavelength of the light will change. We are not going to speak much about the wavelength. We are going to speak much about the speed of the light. How a speed of light will change? When light ray passes from rarer to denser medium, speed will reduce. Correct? When light ray passes from denser to rarer, speed will increase. Correct? So remember one thing, when light ray passes from rarer to denser, speed will reduce. When light ray passes from denser to rarer, speed will increase. But there are so many denser mediums, there are so many rarer mediums. Imagine now, just imagine, there are first three mediums, first medium, second and third. Just this is medium 1, let us take it as air. This is also medium 1, let us take it as air. In all the three cases, first medium is air only. I will write here air. This is also air, this is also air, and this is also air. All the three, first medium is air only. Second medium, this medium I will take it as medium 2, this is medium 3, and this is medium 4. Okay, now a light is passing like this. A light ray passes from here. First I will take this as point of incidence, and this as point of incidence, and this as point of incidence. I will draw normal for first through point of incidence. This is also normal, this is also normal, and this is also normal. Incident light ray came like this with the same angle of incidence. Like this incident light ray came. I said that first medium is common for all the refractions. I did not say anything about the second medium, correct? So second medium also will be having some different refractive index. This is the second medium of first refraction. This is the second medium of second refraction. This is the second medium of this third refraction. What am I trying to say now here? Imagine that this will also, see, concentrate, neatly concentrate and listen, because it is very interesting. It is very interesting. So this medium is second medium for this refraction. This is the second medium for this refraction, and this is the second medium for this refraction. This will be also having some its own optical density. This medium also will be having its own optical density. This medium is also having its own optical density. Correct? Okay. If the but refractive index of the means optical density of these two mediums is different. Correct? If the optical density is different, then only refraction will happen. What is this dotted line you are drawing, sir? This is the extended light ray. Now, if this medium optical density is same, refraction will not happen. Correct? But these two mediums don't have same optical density. I am going to take this as a rarer medium and this as a denser medium. Here also rarer medium and this as denser medium. Here also rarer medium and this as denser medium. All are rarer to denser only. In all the three cases, light is passing from rarer medium to denser medium. Rarer medium to denser medium. Rarer medium to denser medium. Okay. So, in all the cases, light ray should bend towards the normal only. This you must be knowing this already, right? So when the light ray passes from rarer medium to denser medium, the refracted light ray should bend towards the normal. Yes, I accept it. But suppose the difference in optical density of first medium to second medium, yeah, it is rarer, it is denser. Okay, I understand. But what is the difference? What is the difference in optical density? For example, I am saying This is not true. For make you people to understand, I am saying, let us imagine that optical density of first medium is 1 kg. Optical density of this medium is also 1 kg. Sir, what are they taking as kg? No, kg means it is a unit of mass. But I am taking as familiar example to you. So first medium is same. So optical density of first medium is 1 kg. This is also 1 kg. This also will be 1 kg. For example, you imagine, just imagine, okay? Now this is denser medium. So optical density of second medium should be greater than first medium. I will imagine optical density of second medium as 2 kg. And third medium optical density is 5 kg. And this fourth medium optical density is 10 kg. Sir, what is this kg? You just imagine that we are measuring optical density in terms of kg. We don't measure optical density in terms of kg. But I gave you an example to give a similar thing which you are familiar. Okay, now. So now difference in optical density from first medium to second medium is only 1. So how much refraction will happen? Very less refraction will happen. Very less refraction means very less bending. Somewhere here refraction will go. Somewhere refracted light ray will go. Refracted light ray bent towards normal, but the amount of bending is very less. Now here see 1 and 5. The optical density is increased, so amount of refraction will increase. If amount of refraction increases, amount of bending also increases. So see the amount of bending that happened here, more. And here see optical density increased to great extent, so amount of bending also increases to very great extent. So the refracted light ray will be close to the normal here. See the amount of bending here. Understood or not? And you, in all the cases, light ray is passing from rarer to denser medium only. But the optical density of this medium is less, this medium is greater, this medium is greatest. First medium is common for all. So now what happened here? Amount of refraction happened here is less. Why? Because difference in optical density is less. Amount of refraction happened here is more, because difference in optical density has increased. Amount of refraction happened here is still more. Why? Because difference in optical density is still increased. So refraction less, refraction more, refraction most. If more refraction happens, more bending and more reduction in speed. More reduction in speed. And here how much refraction happened? Very less refraction happened. So there will be less reduction in speed. Less reduction in speed. Imagine that speed of light in first medium is, imagine some, this also I am taking an example. These are not 1 kg, 2 kg, 3 kg. These are also not original values. And what I am going to take now, speed values, these are also not original values. But to make you understand, I am taking these values. Okay. So now, imagine speed of light in first medium is 30 meters per second. Here also 30 meters per second. Here also 30 meters per second. How much refraction happened here? Very less refraction happened. So speed of light in the second medium will be around 25 meters per second, because very much less refraction happened, no? And here amount of refraction happened more. So more bending happened. More bending happened means reduction in speed will be more. Here speed of light may be some 20 meters per second. And here what happened? Still more refraction happened. Still more reduction in speed of light will happen. And here speed of light may be 15 meters per second. How did I get these values? I did not get these values from anywhere. I am just explaining the amount of refraction happening here. More amount of refraction happened, more reduction in speed, then speed of light will decrease. When speed of light decreased, then here we can imagine that more refraction happened. Now comes our concept refractive index. Refractive index means index of the refraction. Here also refraction happened, rarer to denser only. Here also refraction happened, rarer to denser only. Here also refraction happened, rarer to denser only. This refraction has some index, that is refractive index. This refraction has some index, that is refractive index of this refraction. This refraction also has some index, that is the refractive index of this refraction. So what refractive index is giving us? Refractive index gives us the whole information what is present in the refraction. You might have studied so many textbooks. Every textbook has some index, correct? What does that index gives us information about the information present in the whole book? In the same way, refractive index also gives us information about the refraction happening here. See, refractive index means it is the index of refraction. It is index of refraction. Does the refractive index has any units? No, it don't have any units. It don't have any units, and it don't have dimensions also. No units, no dimensions, and it will be a value, means a number. It will be a number. So how are we going to measure this refractive index? We are going to measure this refractive index in terms of the speeds. In terms of the speeds, more reduction happened means more refraction happened, means more refractive index. Are you getting my point or not? Clearly, very clearly I am saying. So refraction, if you want to happen, there should be two mediums, correct? If there are two mediums, then we are going to represent refractive index by the symbol like this, neta. We call this symbol as neta. Okay, so now let us take this refractive index, this refraction. We are going to find refractive index of this refraction. So refractive index of how many mediums are there? First medium, second medium, two mediums are there. Second medium with respect to first medium will be equal to V1 divided by V2. This is the only formula you need to remember. Refractive index of second medium with respect to first medium, it will be is equal to V1 divided by V2. And in the same way, if you want to find the refractive index of first medium with respect to second medium, it will be V2 divided by V1. From these two, what can we write? We can write refractive index of first with respect to 2 will be is equal to 1 by refractive index of second with respect to 1. Okay, this is the formula for refractive index. Sir, what did we understand, sir? There is a beautiful concept, that is we are going to measure how much amount of refraction happened here by taking the value of the speeds. If by taking the value of the speeds. Are you getting my point or not? I hope you are understanding. After getting this much explanation, you might have understood all concepts on refractive index. So finally, this is the formula. Refractive index of second medium with respect to first medium will be is equal to V1 divided by V2. Suppose here more reduction happened means V2 will be very less, V1 will be high, correct? So this value will be having higher value. Like that, if the refractive index value is more, then more refraction happened here from rarer to denser. Okay, now why did we take second medium with respect to first medium? Why? Because there is only one medium. If there is only one medium, refraction only will not happen. When will refraction happen? When light passes from one optical medium to another optical medium. When light passes from one optical medium to another optical medium, then only refraction will happen. If there is only one medium, why refraction will happen? Refraction will not happen only. That's why refractive index will be always measured with respect to another medium. Refractive index of first medium with respect to second medium, or second medium with respect to first medium. Always we measure refractive index with respect to another medium. Okay, na? So now let us take a small problem on this formula. What they'll give? They have given speed of light in a glass is 2 into 10 to the power of 8 meters per second, and speed of light in water is 1 into 10 to the power of 8 meters per second. Find the refractive index of glass with respect to water, question mark, and refractive index of water with respect to glass, question mark. So refractive, what is the formula? Refractive index of second medium with respect to first medium will be is equal to V1 divided by V2. Now, in place of 2, 1, we have got refractive index of glass with respect to water. 2, 1 is there. 1 is here, so 1 came here. W is here, VW divided by VG. What is VW? Speed of light in water. How much it is? It is given as 1 into 10 power 8 divided by Vg. Vg is 2 into 10 power 8. So refractive index of glass with respect to water, it is 1 by 2. Now you want to find refractive index of water with respect to glass, it will be 2. 1 by 2 inverse, then 2. Okay, na? So this is about a simple problem. These values are also I have taken to make you familiarize with the problem. Okay. Now this is about the refractive index. There is one more refractive index also, that we call as absolute refractive index. What is this absolute refractive index? See. Absolute refractive index. What did we understand now? We understood that we are going to measure refractive index of any medium with respect to any other medium. Correct? Suppose the first medium is this one, second medium is this one. Any medium it may be. Like this, a refraction will be happening. You will be measuring refractive index of second medium with respect to first medium. Suppose the first medium is always air or vacuum. If you are measuring refractive index of any medium with respect to vacuum or air only, then that refractive index will be absolute refractive index. What is the difference? The difference is very much is there. So much difference is there. Why? Because refractive index of glass with respect to water will not be same as refractive index of glass with respect to air or vacuum. Why? Because imagine that, just what I am saying, just listen here now. This is glass medium and this is glass medium. Second medium is glass. First medium here is water. First medium here is air. Okay, so now I will draw a normal and two mediums I have taken same angle of incidence. Okay, Now this one will be the extended incident ray. What is, if you want to find refractive, imagine that this refracted light ray went like this, and this refracted light ray also went like this. Okay, so now you want to find refractive index of glass with respect to water. It is VW divided by VG. Refractive index of glass with respect to air is VA divided by VG. See, refractive index of glass with respect to water is VW divided by VG. Refractive index of glass with respect to air is VA divided by VG. So same medium, same glass only, but the refractive index of glass with respect to water is having some value, with respect to air is having some other value. Why? Because speed of light in water and speed of light in air is not same. Yes or no? So obviously this value and this value will not be same. So you have to understand that the same glass medium is giving two refractive indices values when measured with respect to water and measured with respect to air. So any second medium may be any medium if you are measuring with respect to air or vacuum. Then that refractive index we call as absolute refractive index. What is the formula for this absolute refractive index? What is the formula for refractive index we know? We know formula for refractive index is N21 is equal to V1 divided by V2. This formula only again reformed as N is equal to C divided by V. What is N? N will be refractive index of any particular medium. V will be speed of light in that particular medium. C will be speed of light in air. See, this one, this one, this one. I'll explain. N21 is equal to V1 by V2. Same, no? NGA is equal to VA by VG. NGW is equal to VW divided by VG. But is these both same? Same. Because first medium is always air or vacuum in absolute refractive index. That's why N is equal to C by V. What is C? C is speed of light in air or vacuum. Speed of light in vacuum. N is equal to C by V. What is N? N will be absolute refractive index of any medium measured with respect to air or vacuum. V will be speed of light in that particular medium. C will be speed of light in vacuum. So taking this formula, N is equal to C by V. So see, N is equal to C by V. What can we understand from here? N is refractive index. N is more, it means that V is less. N is less, it means that V is more. Because see, C is constant here, correct? If C is constant, we can get N proportional to 1 by V. N proportional to 1 by V. N proportional to 1 by V means refractive index of any medium is higher, then speed of light in that medium will be lower. If refractive index of any medium is lower, speed of light in that medium will be higher. I hope you understood this. So now let us take one question. Speed of light in glass. See, speed of light in glass is 2 into 10 power 8 meters per second. What is the refractive index of glass? What is refractive index formula? C divided by V. C is 3 into 10 power 8. C is a constant value. Speed of light in air or vacuum is fixed. It is 3 into 10 power 8. Speed of light in glass is 2 into 10 power 8. 10 power 8, 10 power 8 cancels. Then N will be equal to 3 by 2, 1.5. So refractive index of glass is 1.5. Refractive index of glass is 1.5. Like that, they may give any value. They may ask you to find any value, refractive index value, or they may ask you to find refractive index value, or they may ask you to find the speed of light in that particular medium. They may give this or they may give this. They'll ask you to find the opposite, which is unknown. So now next, n value, next is n value can't be less than 1. Can't be less than 1. Why? Because n is equal to c by v, right? This value wants to be less than 1 means this value should be more than this. Correct? Yes or no? If this n value wants to be less than 1, then this v should be greater than c. What is v here? V is speed of light in any medium. And c is speed of light in air or vacuum. There is no medium in which speed is greater than speed of light in air or vacuum. Light can travel faster only in air or vacuum. It can't travel faster than the speed of light in air or vacuum in any other medium. So V can never be greater than C. So N can never be lesser than 1. V will be always lesser than C. So N will be always greater than 1. This is about the absolute refractive index. Okay. So I hope you understood this absolute refractive index and refractive index. And I'll take one more question. How they will give is, here is one difficult problem I'll take. See, refractive index of glass with respect to air is 3 by 2, you imagine. And refractive index of water with respect to air is 4 by 3, you imagine. Now they will ask you to find what is the refractive index of glass with respect to water. See, they gave refractive index of glass with respect to air is 3 by 2, water with respect to air is 4 by 3. Refractive index of glass with respect to water they ask you to find. Means refractive index of glass with respect to water will be VW divided by Vg. See, remember that formula. Which formula? I'll write here. N21 will be is equal to V1 divided by V2. So NGW is equal to VW divided by Vg. Now we want what? We want the ratio VW divided by Vg. From here we can write NGA is equal to VA divided by Vg, that is equal to 3 by 2. Correct? From here NWA is equal to VA divided by VW, that is equal to 4 by 3. Correct? From here what can I write? VA divided by Vg is equal to 3 by 2. From there Vg, I want VA is equal to 3 by 2 into Vg. So VA into 2 by 3 is equal to Vg. 3 by 2 sent this side, 2 by 3. Now from here VA divided by VW is equal to 4 by 3. So VA is equal to 4 by 3 into VW. So VA into 3 by 4 is equal to VW. VG you got, VW you got. Substitute here. What is VW? VA into 3 by 4 divided by, what is VG? VA into 2 by 3. VA cancels. 3 by 4 into 3 by 2. 9 by 8 is the answer. Okay, na? Now let us solve some previous year questions that are asked in the board examination. After solving these questions, previous year questions you will feel like very easy questions. See, now I will solve one after the other. Right. Speed of light in a vacuum is 3 into 10 power 8 meters per second. If the speed of light in medium is 2 into 2.25 in 10 power 8, absolute refractive index of the medium is. What they asked us to find out? They asked us to find out absolute refractive index n. N formula is what? C divided by V. N is equal to C, we know it is fixed 3 into 10 power 8 divided by V. V did they give or not? They gave 2.25 into 10 power 8. 10 power 8, 10 power 8 cancels. So n is equal to 3 divided by 2.25. This cancellation you need to do. Simple question. Next question, see. Define the term absolute refractive index of a medium. A ray of light enters from vacuum to glass of absolute refractive index 1.5. Find the speed of light in glass. They gave absolute refractive index of glass is 1.5. Find the speed of light in glass. Speed of light in glass Vg we have to find out. What is n formula? N is equal to C by V. N is 1.5 is equal to C is 3 into 10 power 8 divided by V. V we have to find out. Send V this side, 1.5 come this side. So V is equal to 3 into 10 power 8 divided by 1.5. 1.5 and 1.5 so V is equal to 2 into 10 power 8 meters per second. Simple. Next, one more question. What is this? The speed of light in a medium is in a medium A is VA and a medium B is VB. What is refractive index of B with respect to A? We have to find out refractive index of B with respect to A. It will be VA divided by VB. That much only. Next. Absolute refractive index of diamond and water is 2.42 and 1.33 respectively. Find the value of refractive index of water with respect to diamond. That much only, no? See now, they gave refractive index, absolute refractive index, no? So, absolute refractive index of water, it is 2.42. And absolute refractive index of diamond, this is diamond is 2.42 and water is 1.33. Now they asked us to find out absolute refractive index of water with respect to diamond. There is one more formula. Refractive index of 1 with respect to 2 will be is equal to n1 divided by n2. So now if we use this one, NWD is equal to NW divided by ND. What is NW? 1.33. ND is 2.42. That will be 133 divided by 242. This much only. This question, see how nicely they asked simply to confuse students. See what they gave. Absolute refractive index of glass and water is 3 by 2 and 4 by 3. Absolute refractive index of glass is 3 by 2 and absolute refractive index of water is 4 by 3 respectively. Okay. If the speed of light in glass is 2 into 10 power 8. Speed of light in glass is 2 into 10 power 8 meters per second. Find the speed of light in water. This is the question. See, if you observe neatly, this much is only sufficient to solve the question. Why they gave this? Simply to confuse. See, what is refractive index of water? C divided by speed of light in water. That much only, no? So now, this they gave, it is 4 by 3 is equal to C, we know C value is 3 into 10 power 8 divided by VW. Substitute the values, no? VW is in this side, 4 by 3 into VW is equal to 3 into 10 power 8. So VW is equal to 3 into 10 power 8. 4 by 3 comes this side, 3 by 4. So VW is equal to 3 3 cha 9 into 10 power 8 divided by 4 meters per second. This much only. So simply unnecessarily they gave this one to confuse. This much information is sufficient, right? Right. So this is about the refractive index and absolute refractive index and some simple problems and also some complicated problems and also some previous year question problems on refractive index. Hope you all enjoyed this video and learned some information about refractive index. Thank you so much. Keep learning. Stay happy. Thank you.